Hey, I'm Matt Martz. I'm a lead engineer at PowerSchool and an AWS community builder, and I'm here to talk to you about creating verifiable JSON Web Tokens with CDK, or really, how to secure your grocery lists. So the Martz family stores our grocery lists in JSON Web Token format, like everyone else. The problem is we don't actually verify the tokens. So someone could swap out the token on the fridge and include things like candy or junk food, and we wouldn't really be able to tell. So let's spin up a CDK stack that will sign the JWTs and serve the key store so the JWTs can be verified. The stack's going to consist of a RestAPI, a secret and secrets manager, and an S3 bucket. There's also 3 lambdas. One of these lambdas is going to be invoked by a custom resource, and that's going to be used to generate the public and private keys and store them in S3 and secrets manager respectively. Another lambda is going to read the secret and generate the JWT using it, and the other is going to use an AWS integration with S3 to get the key store and actually verify it. So to set up the project, we are going to use projen. Projen's really handy for setting up proof of concept projects. You can run this command, and pretty much it gets spun up very quickly. Then we just need to install a couple extra dependencies. So in this case, we're going to install these, and this will take care of everything that we need for the rest of the project. Once the dependencies are installed, we're going to create the S3 bucket and the secret. These are only a couple lines of code. Creating the secret's really easy. Basically, just give it a secret ID, and then the bucket itself follows the same pattern as other buckets. One thing I want to point out is this auto-delete objects. Auto-delete objects, when you destroy the stack, will actually create a custom resource that will empty the bucket before trying to delete it. Otherwise, it wouldn't be able to destroy the bucket if there's stuff still inside of it. So, very useful. In order to generate the keys, we need to create a custom resource. This is going to generate the key store and store the private key and secrets manager and the public key in S3. We don't want this to generate the key store every time we deploy the stack, so we're going to use custom resource versioning. Basically, what this does is every time the stack deploys, it's going to check the stuff inside of properties, and if like the version changes, it will re-execute the custom resource. So if I keep it at 2 forever, it's only going to do it the first time it goes out. Creating lambdas in CDK are pretty straightforward. We're going to give it some lambdas. We're going to use Node.js function because it's super easy. You don't have to install. I like using TypeScript, so it just uses esbuild to bundle, and if you install that natively, it's very fast. So we're going to create the Node.js function. Give it access to write to the secret, and give it access to write to the bucket that we created earlier. Once the key store is created, it then actually writes it. This is a really simple handler function. It gets the secrets manager from the AWS SDK, and it gets the S3 client from AWS SDK, and that it uses the create key store functionality to store both the secret and the public key, respectively. So we're going to store the public key in a JWTs.json file in the bucket, and really that's going to be the only file that's in that bucket. But we'll use that later. For now, we're going to use the secret. To create the JWT, we want a REST endpoint that we can post to that will basically encode whatever payload we give it and sign it with the secret that we just created. So in order to do that, we're going to create the REST API, create the encoder function, and grant it access to read the secret. And then we're just going to add the resource and method for the Lambda integration. The signing of the actual token is easy in that it just takes the event body and uses that as the token payload, and it gets the secret value from secrets manager and just signs it. From there, it returns the signed token, and you have a valid JWT. So this is what that looks like. Once the code is deployed, you can make a curl post or use Postman or anything else for that matter, and include the grocery list, and it will get encoded into this JWT. So if you were to take this and put it into like JWT.io or whatever, you'll see the grocery list here. But we're not actually verifying it. But you know, that's been fine for now. We haven't really had too many slip-ups with the Martz family grocery list. But I think Veronica may have overheard me tell Mom that we weren't verifying the signatures, so she figured out how to just generate her own JWT. So that's pretty easy to do. You can go to a lot of websites, just copy the original token, make some slight modifications, and replace healthy stuff with candy. And it looks the same. I mean, we weren't verifying it before. Looks good to me, right? So let's fix that. We're going to serve up the key store. So serving up the key store is actually pretty neat. So we stored the public key in S3. Instead of having like a lambda return it or something like that, what we can do is we can create an AWS integration using some of the CDK stuff. So we're going to create a role. You need to create a role, and basically it gets assumed by API gateway, and we're going to grant it access to the bucket. Then we create the AWS integration, and it's for the S3 service. So the role credentials go here. We're just going to give it a simple path like this. We only want it to access this one file. You can wildcard these and get it so that you have an AWS integration for S3 that you can use to access a lot of files, but we only want it to do this single file. And then something important to note is integration responses. Integration responses are required in this case. If you don't include this, what will happen is the API gateway will be able to get the file from S3, but it's not expecting a 200 response from S3, so it's actually going to replace it with a 400, and you don't get your file. You could see this in the API gateway console by actually test invoking the endpoint. You'll see it successfully gets the S3 file, but then if you were to actually make the curl request to get the key store, you'd get a 400. It was pretty frustrating to troubleshoot, but you need this step. And then we just define the endpoint. So in order to actually verify the JWT, we need to create the decoder lambda. What that's going to do is, normally you wouldn't do this, but for the sake of demo, we're actually going to pass in the key store URL that we actually want to use to verify. Normally this would be encoded in your lambda, and it would only be coming from one place. It would probably be an environment variable or something. But for ease, we're passing it in. So what this lambda is going to do is it's going to read it's going to hit the key store URL, get the keys, and it's going to look for the key ID that's encoded in the token. And if it's not there, well, it wasn't signed by that key store. So now, if we pass in the grocery list, the good one comes back and just returns back the actual grocery list that we should have. Whereas the bad one returns an error, and it's like, well, we didn't sign this. So now we know Veronica was trying to add something to the list, and we shouldn't use that. Now, I know it's hard to believe, but we don't actually use JWTs for our grocery lists. But it's really easy to set this kind of stuff up, so verify your JWTs. Also, I strongly recommend using ESBuild with Node.js function. Make sure you install ESBuild locally. It works super fast. It's great. And then I think the other thing I pointed out was the auto-delete objects in S3, also for the S3 buckets, also very useful when you're destroying your stacks. The slides for this, the blog post that goes with it, and the code have all been tweeted out by now. So thanks for watching my presentation.